Draw the following angle in standard position. First of all, it says just 3. Usually when we don't see the degree sign, it means radian. So when we see just a number and it's referring to an angle, it is implied that it is a radian. Unless we see like degree sign, usually that means it's 3 degrees. So here we're dealing with 3 radian. So in standard position, an xy coordinate, we start, this is initial ray, we start from here. We can pick any radius, let's say this length, right here is radius. 3 radian means that the arc length created by the angle is 3 times as large as the radius length. So here's about 1 radian, there's arc length the same as this. There's 1 radian, 2 radian, right here. 3 radian will be somewhere here. So this angle right here is 3 radian. So we can say this arc length is created by angle 3. And remember, pi, which is about 3.14 and unending decimal, was exactly this right here. Therefore, 3 radian should be a little less than pi, which is right here. So this is a terminal ray. So let me mark it this way. Here's the initial ray. Here's the terminal ray. And this angle refers to 3 radian. Draw the following angle in standard position. Here, 5 pi over 3. Again, the pi itself does not make it radian. The fact that there's no degree sign, we can assume that this is radian. So how do you approach this? Again, we're sketching an angle at a approximate. So we know that pi is about 3.14. So we have 5 times 3.14 over 3, which is 15.70. So this is about 5 pi over 3. And we can look at this number, which is also close to about 5.23. So what we conclude is that 5 pi over 3 in decimal is close to 5.23 radian. Again, this is an approximate because it would be unending decimal. So we can just try to draw 5.23 radian in standard position. So in standard position, we start from radius here. Let's say initial ray. Start from here. And here is about 1 radian, 2 radian, 3 radian, 4, 5 radian. So this is 5. So for this 5 pi over 3, we have to go a little more. We have to go about 2.3 more, so we'll just go a little more. So a little bigger than 5 radian. So the angle starts from here and ends right here. So this angle is about 5 pi over 3. Now, what we're practicing here is conceptually try to understand what radian means. Okay, so we want to do this without relying on degrees. And if you also remember from the unit circle, this angle is also located in unit circle, which is, again, located here. So this angle is the answer. Now let's look at this one. Draw the angle in standard position to 80 degrees. So again, standard position just means we have x and y coordinate, and we start from initial ray right here. And we know that in terms of degrees, this is 90, 90. So this is 180 degree, and add another 90, 270, and let's go a little more for 280 degree. So maybe we'll move out this much more for 280 degree. and this is the terminal ray. So this angle right here, represents 280 degrees. As you can see, there's a degree sign. That's how we know this is in degrees. Find an angle coterminal to given angle in the interval 0 to 360 degrees. So for 600 degrees, you want to find a coterminal angle that is in the range of 0 to 360 degrees. So for these, since 600 is bigger than 360, we can start subtracting. So 600 minus 360 will give us 240 degrees. And 240 degrees in this range. So 240 is coterminal with 600. And let's just try to sketch this to review the idea of coterminal. Coterminal means it shares terminal. So for example, 240 degrees, let's start from here, is 180, and 240 goes 60 more. It's right here. This is 240 degrees. Whereas 600 also starts from here. It goes to 361st, so it goes all the way here. Then it goes 240 degrees a little more. So it ends up the same place. That's why they're coterminal. Of course, there are infinite number of coterminal angles for each angle, but for this problem, they're specifically asking between 0 and 360 degrees, which is also the degrees given in unit circle. Find an angle coterminal to given angle in the interval 0 to 360 degrees. Now we're given negative 34 degrees. Negative angle, the way we think about negative angle is it just goes to opposite direction. So it starts from right here. Positive angle go to counterclockwise this way. But since it's negative, it will go clockwise. So you move this way about 34 degrees, which is, let's say somewhere about here. So this angle with this direction is negative 34 degrees. So if you want to find a coterminal angle between 0 and 360 degrees, we can just add 360 degrees. So if you add 360 degrees, we get 326 degrees. So how does 326 will look like on the graph or on the x and y coordinate? Again, still same initial ray, but 326 will be this one right here, like this angle. Now this is positive angle. That's why we move counterclockwise. Find an angle coterminal to the given radian in the interval 0 and 2 pi. Now we're dealing with radian. So let's first check something. This is about 5.9 pi. About. If I do 17 divided by 3, if it were to be 18, it would be exactly 6 pi, right? So if I do 17 divided by 3, 5.6, so it's not 5.9. It's about 5.6 pi, about. And the point of doing this is just to show that this angle right here is bigger than 2 pi. So it's out of the given range, given interval. So what we have to do is we have to subtract full rotation until we get an angle between 0 and 2 pi. So we start from 17 pi over 3, and we subtract 2 pi, because 2 pi is the full rotation in radian. But 2 pi, in order to subtract these two numbers, we have to have a common denominator. So the way we write it is 17 pi over 3 minus 6 pi over 2. Over 3, to have a common denominator. And 6 divided by 3 is 2. So we're subtracting same quantity of angle. Then if we do this, we get 11 pi over 3. Now 11 pi over 3 is also bigger than 2 pi because this is about 3 point, let's see, so 3 goes to 11 3 times, which is 9. Remainder is 2. So again, still about 3.6 pi. So again, this tells us that this is still out of this range right here. So from this angle, we subtract again. From 11 pi over 3, we subtract 2 pi again, which is again 6 pi over 3. Gives us 5 pi over 3. Now 5 pi over 3, we know that it's less than 2 pi. Because if it were to be greater than 2 pi, this number right here has to be greater than 6. So this is the answer. This is a coterminal angle to 17 pi over 3 that is between 0 and 2 pi. Find the angle coterminal to the given radian in the interval 0 and 2 pi. Now here we are given negative 11 pi over 4. So it's a negative angle, which we know is now smaller than 0. Okay? So it's smaller than 0. That means we have to add 2 pi until we get an angle between 0 and 2 pi. So we had a full rotation. So let's start 11 pi, negative 11 pi over 4. We're going to add 2 pi. In order to add these two numbers, we need to have a common denominator. So instead of 2 pi, I'm going to write 8 pi over 4, which gives me negative 3 pi over 4. Still a negative number. So from here, and we're going to start a new line, we're going to add 2 pi again. We don't know why add 2 pi here, because then we're claiming that this equals this, which is not true. So we have to start from new line or the separate work showing that we got this. Now from here, I'm going to add 2 pi again. Just 8 pi over 4 gives me 5 pi over 4. So now this angle is positive and is between 0 and 2 pi. It's less than 2 pi and it's greater than 0 radian. So this is a coterminal angle that is between 0 and 2 pi for this angle. Below is a diagram of a Ferris wheel. Suppose there's only one cart A, and the cart A rotates counterclockwise. 1 to 11 are all other stopping positions. The cart A will stop for 2 minutes. All the stopping points are equally spaced. What is the angle measure between each stopping point position in radians? So in this problem, the cart starts from here and start rotating this way, so counterclockwise. And it will stop at each position for 2 minutes. So the question is asking if they are equally spaced. Oops, sorry. So this angle, all these are same, equally spaced. Or we can also think as this same arc length, or these are same arc length right here. All these are same arc length. So what is the angle measure between each stopping points? So let's see. First, how many spaces are there? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 equal spaces. And we know that the entire full rotation angle is 2 pi. Therefore, 2 pi divided by 12, which simplifies to pi over 6, is the angle between each stopping point. So this is pi over 6, this is pi over 6, all of them are same, pi over 6 right here. Okay. So pi over 6 is the answer. In this problem, again, we know that they're equally spaced, and each of these are pi over 6. They're equally spaced, they're all same. Okay. And the question is asking, what is the angle measure between stopping point 6, let's mark it right, stopping point 6 and stopping point 10. What is this angle measure? Okay. So essentially, what is this angle measure again? we know that each space is pi over 6. So we have 1, 2, 3, 4. So we just do pi over 6 times 4, which is 4 pi over 6, which is 2 pi over 3. So between card 6 and card 10, the angle measure is 2 pi over 3 radian. And also, right, that means from initial position to 4 is also 2 pi over 3. Right, since we have a 4 equal space. So just 4 times pi over 6. If the radius of the Ferris wheel is 15 meters, so this is 15 meters right here. This length is 15 meters. What is the total distance car A traveled from initial point, so from here to position 7? So again, we know that they're equally spaced, and they're 12 spaces, so we know each space is pi over 6. So first, in order to find this distance, so in this case, they're asking actually this arc length. What is this arc length? Remember, radian is arc length measured in radius length. So first, we need to find the angle first. What is this angle? We have 1, 2, 3, 4, 5, 6, 7. We have 7 equal spaced, each of them pi over 6 radian. So we know that angle is 7 pi over 6. So this is the angle. Angle between initial position and stopping position 7. But this is measured in radius length, right? This angle. But this is assuming when radius is 1. So since now it tells us the radius is 15 meters, the arc length is the radius length times the angle. So in this case, radius is 15 meters. Angle is 7 pi over 6. So the answer is, let's simplify this a little bit. 2 times 3, 5 times 3. So we have 35 pi over 2 meters. So that means this arc length now is 35 pi over 2 meter. And this is one of the benefits of using radian. It allows to calculate the arc length directly. Okay. And let's look at this. It is essentially just solving for another variable, since we know that angle is arc length divided by radius in radian, right? But in this case, I solve for arc length by multiplying by the radian angle both sides. Or radius both sides. Now this context of problem also can raise another question using sine and cosine. Since sine measures vertical distance, right, for example, when A moves to the initial position to position 3, what's happening to sine function? Sine measures vertical distance. So here, and vertical distance 0. So we know that vertical distance is actually increasing because this is negative, little bigger negative, now 0. So a sine function from A to 3 is actually increasing. Also, a sine function from position 3 to position 6, from here to here. Look at this. Start at 0. Vertical distance is increasing. So sine function is actually increasing from entirety of A to 6. Well, you see that from 6 to A, now sine function will decrease, because now this vertical heights are decreasing, right? Decreasing now becomes negative, smaller number. Since sine function measures vertical distance divided by radius length. So Just another context to think about your sine function. And we can also do a cosine function, which in this case we're using the horizontal distance. Explain what an angle of 1.6 radian means in terms of radius and arc length. So angle is 1.6 radian. And if you want to think just strictly in terms of equation, we know that radian is arc length divided by radius length. We want to think a little more about this. This means that how many times does arc length can go into the arc length? And that's what dividing means, right? If I have eight slices pizza and I want to divide it to 4 people, I do 8 divided by 4. How many 4 people can go into 8 slices pizza twice? Similar idea. That's what division means in whole numbers, right? And what that also means not whole numbers too. So contextually, what this means that 1.6 radian means that the angle, if I have an angle like this, I'm just sketching an angle. If this is radius, this is radius. This arc length is 1.6 times as large as the radius length for this angle. So let me write that in a sentence. The arc length created by angle 1.6 radian means the arc length created by angle 1.6 radian is 1.6 times as large as the radius length. That's what it means. So for example, if radius is 10 centimeter, arc length will be 16 centimeters. If radius is 5, then 1.6 times 5 will give us the arc length. That's what it means. Explain what an angle of 0.3 radian means in terms of radius and arc length. So let's do a quick sketch of this angle. Here's the standard position. Let's say we have this radius. This is radius of a circle. And 0.3 means that 0.3 radian means that this angle, if this angle is 0.3 radian, that means that this arc length right here created by this angle is 0.3 times radius. We can do this 0.3 times the radius length. That's what it means. So again, let's explain in context, in words. This means that the arc length is 0.3 times as large as the radius length. Yeah, and we just say large as in we multiply 0.3 because obviously the arc length is not bigger than radius in this angle, right? But times as large. Since we're multiplying number less than 1, yes, it is implied that the arc length will be smaller than radius. Drawn an angle theta such that sine theta is negative and tangent theta is also negative. So here, let's review what sine theta represents. It represents vertical distance. Vertical distance measured in radius length, right? So measured in radius length. Tangent represents the slope of terminal ray. Slope of terminal ray. So sine, let me draw here, vertical distance of what, right? So vertical distance Let's have this angle. It measures vertical distance from horizontal diameter of circle. So we can imagine we have a circle here. From horizontal diameter right here. It measures this vertical distance to the terminal ray of the angle, measured in radius length. So we do this vertical distance divided by radius. That's what sine measures. In unit circle, the radius is 1. That's why we just have the y coordinate as sine theta value. So let's try to draw this angle. And here, there's many angles. You just need to draw one. Essentially, as long as you find the correct quadrant to draw an angle, that means these two conditions, we have a correct angle because it's drawn on angle, right? There's an infinite number of these. So first, let's look at sine is negative. That means the vertical distance has to be negative. So that means either here or here, third and fourth quadrant. Because that's when sine and cosine are negative. Because vertical distances are negative on third and fourth quadrant. Now slope is negative. When is tangent negative? That means when slope is negative. Slope negative means that we have a line looks like this direction. These are all negative slope. Positive slope so that looks like this, right? Rise over 1, both are positive. But here, when x increases, y decreases. X increases, y decreases. So the angle that in fourth quadrant, let's say something like this right here. Slope is negative, and so initial raise here. This angle here, for example, has this slope is negative. Slope of this ray is negative number, and sine, which is this value, divided by radius, is also negative. If you draw an angle on third quadrant, sine is still negative, but then, for example, slope of this is positive. So here you can draw this angle, and just any angle in fourth quadrant is fine. This one's fine, this one's fine. There are many answers, but the important thing is that for this two condition, the angle must be on fourth quadrant. Draw an angle theta says that sine theta is positive and cosine theta is negative. Sine theta measures vertical distance measured in radius length. Cosine measures horizontal distance measured in radius length. So let's review that real quick. If you have an angle here, for example, this one, sine measures this distance, vertical distance from horizontal diameter of a circle to terminal ray, this distance, measured in radius length. So that's what we divide by this radius. Cosine measures this distance, or this distance, same thing, measured in radius length. So here essentially is asking when is the vertical distance positive and horizontal distance negative in terms of an angle. So sine is positive, that means it has to be first two quadrant, because that's when the vertical distance is positive. Cosine negative means when x value is negative. So any angle in second quadrant would work in this case. So maybe something like this. Start from initial ray, stop here. So important thing is drawing an angle in second quadrant. So we can check here. Yeah, sine value measures this distance divided by radius length. And we can see that this is some kind of positive number. And we always consider radius as positive. So we have a positive divided by positive, we have a positive number. For cosine, we're measuring this distance, which is negative, right? Since we're going left from the y-axis, this is negative number divided by radius length will give us negative number. So any angle that you draw on the second quadrant will be the correct answer for this problem. Evaluate each. For these problems, essentially we're practicing using unit circle. So you definitely need to be able to draw or construct your own unit circle. Okay. So before you try this problem, construct unit circle on a blank piece of paper on your own, and then we can go over this. We can check the answers. So pause the video, draw your own unit circle first, then come back. Okay, so let's look at this. On the unit circle, sine pi over 3. On unit circle, the y coordinate represents sine. Again, it's because sine of that angle measures vertical distance, and y is the vertical distance. So here, sine pi over 3. Again, this is when angle pi over. Sometimes we have parentheses, sometimes we don't. Sine pi over 3 means input is angle. What is output? Output is square 3 over 2. Cosine 2 pi over 3. From unit circle, again, we'll look at the x coordinate, which is horizontal distance. In this case, negative half. Cosecant pi over 6 is same as 1 over sine of pi over 6. Because cosecant is same as 1 over sine. So let's find sine of pi over 6. Then we can do 1 over the number. Sine pi over 6 is half. So then we have 1 times, dividing a fraction is the same thing as multiplying its reciprocal. So we do this, which we get 2. So cosecant of pi over 6 is 2. Tangent pi over 6 is asking us to find the slope of the angle pi over 6, the terminal ray of the angle pi over 6, which we can find by finding rise over 1. But in unit circle, rise represents vertical distance, which is sine value, and over run represents horizontal distance, which is cosine value. So this is the equivalent of finding sine of pi over 6 divided by cosine of pi over 6. And from the unit circle, sine of pi over 6 is 1 over 2. And cosine of pi over 6 is square 3 over 2. Dividing a fraction is the same thing as multiplying reciprocal. So I'm going to multiply 2 over square 3, which is 1 over square 3. We can rationalize this by multiplying square 3 over square 3, which is square 3 over 3. Let's look at sine 31 pi over 3. You notice that 31 pi over 3 is not on unit circle. So that means that we need to find the angle that is coterminal to 31 pi over 3. And then we can find the sine of that angle. So we could keep subtracting 2 pi until we get an angle. But there's a little faster way. So you can keep subtracting 2 pi. But we know that 31 pi over 3 is about 10. Let's see, 10.33 pi. So it's 10 and some decimal. Okay. So 10 pi, that means we can subtract, since 2 pi is full rotation, we can subtract 5 full rotation. So from 31 pi over 3, we can subtract 5 full rotation, like this. 5 full rotation. So then we can have a common denominator. This is 10 pi, which is 30 pi over 3, which is pi over 3. So pi over 3 is coterminal to 31 pi over 3. So on unit circle, we need to find this, which is square 3 over 2. So this, because of coterminal angle, sine gives us same value, sine 31 pi over 3. Sine 31 pi over 3 equals to sine pi over 3, which is square 3 over 2. Let's look at secant of negative pi over 2, which we can rewrite as secant of negative 4 pi. So we can also take care of this angle right here. Negative 4 pi is not a unit circle. So we can add 2 pi until we get angle between 0 and 2 pi. So here, negative 4 pi plus 2 times 2 pi. Let's add full rotation. We'll get 0. So negative 4 pi is equivalent to 0 radian. So this is the same thing as secant of 0 radian. And secant is 1 over cosine, so we need to find 1 over cosine of 0. And cosine of 0 is 1. So we have 1 over 1, which is 1. So secant of negative 8 pi over 2 equals 1. Sine of negative pi over 6. So here we have two ways of doing this. We could add 2 pi until we get a coterminal angle. But another way to think about this is negative pi over 6 means that we start from here, initial ray, and we go negative pi over 6 this amount. This is what going negative direction means. Okay. And if you look at your unit circle, that is same thing as, so coterminal is 11 pi over 6. This is also 11 pi over 6 if you look at this angle. And this is essentially what we get if we find the coterminal angle. So we can do negative pi over 6 plus 2 pi, which is 12 pi over 6, which is 11 pi over 6. So this will give us same value as 11 pi over 6, which on unit circle is negative half. Cotangent of pi over 4. Cotangent is same as tangent, 1 over tangent. So 1 over tangent of pi over 4. And tangent is same as sine pi over 4 over cosine pi over 4. And we can rewrite this again. Dividing a fraction is the same thing as multiplying reciprocal. So we can do 1 times cosine of pi over 4 over sine of pi over 4. And cosine of pi over 4 is square root 2 over 2. Sine of pi over 4 is square root 2 over 2. They're the same number top and bottom, so we get 1. Using the triangle, find the sine, cosine, tangent, cosecant, secant, and cotangent of the angle A. Okay, so actually, this is supposed to be angle A right here. Okay, so this angle. So here, we're given a right triangle, which we can also think as we have a circle with radius 13. That's another way to think about it, like this. We have a circle, full circle. So here, we can actually find this length h using Pythagorean theorem. Pythagorean theorem tells us that the longest length of a triangle, square, equals other two sides. This is 169 equals h squared 144. H squared equals 169 minus 144, which is 25. And h is 5. So we know h is 5. So now we know the three sides of all the length. We can find sine, cosine, tangent, and cosecant, secant, cotangent. So sine of this angle A is, if we think in terms of vertical distance, is this distance divided by radius length. So 5 over 13. We can also think as opposite over hypotenuse, which we get the same answer. Cosine of angle is horizontal distance 12 divided by radius. And tangent is the slope of this angle right here, this slope. So let's do sine over cosine. Actually, if we think this in terms of x and y coordinate, it will make more sense to have this as negative length, right? So let's, for the purpose of that, let's just make it negative 12. So then tangent will be 5 over 13 divided by negative 12 over 13, which simplifies to negative 5 over 12. But when we find So let's find cosecant, secant, cotangent. Cosecant is reciprocal of sine, since we're doing 1 over this thing, so it's just 13 over 5. Secant is reciprocal of this, which is 13 over negative 12. Or again, negative sign can be also in the front, like this. Reciprocal. Cotangent is reciprocal of tangent, which is negative 12 over 5. So once we find sine, cosine, tangent, we can just change the location of denominator and numerator to find cosecant, secant, cotangent. Using the triangle, find sine, cosine, tangent, cosecant, secant, and cotangent of angle A. Here they actually give us this angle 45, and this is 90, then this also must be 45 degree. Okay. So even if they give us the length here, let's say it's like h, maybe this is 5, because we know the angle, we can just use sine, cosine, tangent 45 degree to find the values. So sine of 45 degree, cosine of 45 degree, tangent of 45 degree. So if we're given an angle, if you can find an angle that is a unit circle, and if we want to evaluate sine, cosine, tangent using that angle from unit circle, we don't need to rely on the length of the right triangle. So we know that sine 45 degree is square root over 2 from unit circle. Cosine 45 degree is also square root over 2. And tangent is sine over cosine, and since they're dividing same number, it is just 1. So then when we find cosecant of 45 degree, it's reciprocal of this. So it'll be 2 over square root 2. We can rationalize by multiplying by square root over square root 2, which is 2 square root 2 over 2, which just simplifies to square root 2. So cosecant 45 is square root 2. Secant of 45 degree, reciprocal of this, 2 over square root 2. We can again rationalize by multiplying square root over square root 2, which is 2 square root 2 over 2 square root 2. Cotangent is just 1 over 1, which is 1.